Right, so we'll just quickly start a drawing for this one and just show how we put in the thread information for clearance holes and internal threads. So I'm just going to save it as the valve flange. Then I'll start a new ISO.idw. Going to place the base view just very quickly here. I'll just set it out like this. And just in order to get to show you guys, I'm going to create a section through it. And put it over here. So here we get the same lines as we got on the external threads. Only here we get them shown into the material of our part instead. So once we're going to put dimensions in here, it's exactly the same as we did with the external threads. We're going to use the hole and thread feature, and we can click on the thin lines here that show us the maximum diameter of the threads, and we can click on the other side also, and then we get it shown as a diameter, and it's a bit more easy to read once you put it up like this. I don't think we can do the same for the clearance hole. I doubt that we can put it. No, we can put the clearance hole as a diameter. So we have to put that one up like this. With the clearance hole, it is possible to add extra information. So since we've used the clearance hole function when we created the 3D model, we can start adding information in here. So we might want to know what kind of bolt is going to go through here, the fastener type. So we can put that in. We might want to know the size of the fastener. And we might also want to know the fit value, if it's a close or a normal or loose fitting. If I click OK here now, you will see that for this, let's see here, for this 13mm hole, we are supposed to put a hexagonal head cap screw from this ISO standard through it, and it's going to be an M12 bolt, and it has a close fit. So we can get all of this information that we put into our 3D model, we can put all of that into our drawing also. It's not always necessary to put all of this in, but it is a possibility to do it. I'll just go quickly back in here to show you where you get all of these informations. And it's basically where you can see that there is a bolt and a nut. So those three there are the different informations, different lines. So you double click on the dimension. It's the three ones that actually show a bolt head. So the first one is what kind of bolt it is. So in this case, the hexagonal head cap screw. The second one is the thread size, which is M12, and the third one is the fitting that is to it, if it's close or loose or normal. So it is possible to put quite a lot of information in on this one. Yeah, I have those also up top. Yeah. So those are the 13mm diameter and going all the way through. Yeah, then you have the you don't have default method 1B on if you have it on a line. Yeah, you should use the default method 1B because that's what's going to create this angle on your line so that you get it the correct way. Hmm? Yeah, okay, okay for me. Yeah, yeah. Oh, ja, ja. Ja. Det burde de vite. Det ligger på front og ro. Ja. Just going to save this drawing quickly, and then I'm going to start on the next part. Which is the wheel. I really hope we can manage to get the two last parts done today so that we can do the assembly and animation next time. So we'll start a new part on this one. And we click create on the standard millimeter IPT. And what we're going to create now is the wheel that's going to be attached to the shaft so that we can rotate it and open and close the valve. So we'll start off by creating the center of our wheel. So we create a new sketch. And the center of our wheel is basically just a disc, so we're just going to create a circle in the middle. And it's supposed to have a diameter of, let's see, it's supposed to have a radius of 36. So it's going to be 2 times 36 in order to get the diameter. So a diameter of 72. Then we'll finish the sketch and do an extrusion. And it's supposed to be 12.5 millimeters thick. So 12.5 millimeters thick. Radius of 36. So. Hmm? 12.5 in thickness. Then we'll create a new sketch on top of this disc. And we're going to put 2 new circles in here. So we'll start off with one circle. And it's supposed to have a diameter of 146 millimeters. Then we'll create one more circle. And it's supposed to have a radius of 86.5. So 2 times 86.5, giving us 173. So this will be the outer ring of our wheel. And we'll click Finish Sketch once we've gotten those two in place. Now the important thing now is to, when we extrude this one, we need it to go upwards because it's going to be above the center disc that we have. So we're going to do extrude, and we're going to select the outer circle that we have here. And we need to double check in our 3D model, so let's look at it from a side. We need to make very sure that it's starting from the top of our disc and going straight upwards. And this one is supposed to have a thickness of 19 millimeters. Once this is done, we're going to have to create one of the spokes of the wheel. And then we're going to use a circular pattern to create the rest of them. So as we can see from the drawing, we're supposed to have 6 spokes. So if we can create one of them with a sketch and extrude it, then we're going to be able to create, use a circular pattern and create the rest of them. So we put this one in place there. So now I'm going to look at it from the front here. And I'm going to have to open up the origin folder in my browser tree over here. And I'm going to have to figure out which of the planes I'm looking straight at right now. So the YZ plane is at a 90-degree angle from me. The XZ plane is also at a 90-degree angle. But the XY plane, that one, I can put a sketch on that one. I'm going to just tilt it a little bit here, so that you get to see. If I have the XY plane, it's going to cut straight through the center of my part, which means that I can create a sketch going from the disc in the middle and up to the wheel, and then I can extrude it symmetrically in both directions, and I'm going to have one of the spokes. So that's what we're going to start doing now. So I'm going to go to start a new 2D sketch. I'll go down to the XY plane there, and I'm going to click on that one. And this is where the F7 button comes in real handy. So now we'll click F7, and it's cut away half of our parts, so that we can actually see the middle of the part here. One thing that's going to help us quite a lot here when we have this cut view of it is to go up to the project geometry part here, and we're going to do the drop down menu, and we're going to tell Inventor to project all of our cut edges, and that means the ones that it's actually cutting through in our sketch here. So then we actually get the outline of the outer ring, and we get the outline of the middle of the disc. So what we're going to have to do now is to create our spoke going from the disc and up to the outer ring. And in order to get the spoke to be look as it's supposed to do, we're going to have to do some slight modifications to it. We can't just create a sketch from this edge to that edge, because once we start extruding it, everything is going to be fine up here, because here we have a curve going this way, so that it's just going to be extruding into the material on the sides, so that's not a problem. But down here the curve is going this way, so it's bending away from our extrusion, and so we're going to have an opening between the disc and the extrusion, which means that we are going to have to pull our extrusion somewhat into our disc here in order to avoid this. I can show it a bit better if I flip my view a little bit there. So once I start my extrusion from this center plane and extrude both ways, we can see that I'm going to have an opening here between my extrusion and the disc there. It's not going to be a problem over here because my extrusion is just going to go into the material and it's just going to fuse together, so that's going to be fine. But over here we will have a slight problem. Which means that we have to take a little look at how it's been done in the compendium. And we're going to start to have to create lines for this. So I'm going to zoom in quite a bit on the end of the disc here, just so that we get to see it nice and big when we're doing it. So we're going to have a vertical line on the inside here, going straight up and down, but not all the way to the edges. It's just going from slightly inside and somewhat down here. Then we're going to pull it over to the edge here in a, not in a straight line. We're actually going to go straight up to the outer circle, and up here we can actually attach it to the edge of the outer circle. Not a problem. Then we'll create a new line going up here somewhat, and we'll have another line going back down and connecting to the starting point of our original line. So if I zoom a bit out again here, we're going to see that we now have this shape. So it's connected to the edge of the outer ring, and it's somewhat into the disc on the other side here. Now, in order to get this as perfect as possible, if you're doing this from scratch, you don't have a compendium to look at or anything like that, it is usually necessary to do the extrusion and then go back into the sketch, fix a little bit on the distances that you are going to put in here, and try again, see how it looks, and then back and forth a little bit until you get to adjust it perfectly. Luckily for you, this is something I did this summer when I created the compendium, so we don't have to go back and forth now in order to create this. What I figured out was that a distance of 0.55 millimeters from the edge of the disc and into this line. That is what we're going to need. So we're going to put a dimension in here between those two lines and 0.55. So half a millimeter, that's all we need. And later on we're going to have a 2 millimeter fillet on the edges of the disc and also on the edges of the circle or the ring, outer ring. So we're going to want to have a 2 millimeter distance from the edges here. That's why we didn't attach them completely. So from the top point here and to the top line, we put in a 2 millimeter distance. That means that we will have a nice fillet over here. And from this one to that one, we also want a 2 millimeter. Then we do the same up here. From the bottom point of the line and to the bottom of the ring, 2 millimeters. And from the top of the ring to the top of the line, 2 millimeters. So now we have the outline of the spoke itself. But as you can see from the drawing, we're going to also have a slight knob on the end here where the spoke is. So we're going to put in a rectangle here also. So we're going to place a rectangle. We're not going to attach it to anything right now. We're just going to set it up here. Because with this rectangle, we're going to have the same problem as we had over here, because now our ring is curving away from our extrusion, so that we're going to have it go into the extrusion there also. And we're going to use 0.55 here also. But then we want this part, which is actually outside the ring, we want that part to protrude 6 millimeters out. So we need to go from the edge of the ring and to the edge of the rectangle and set it to be 6 millimeters. Which means that the total width of our rectangle is 6.55 millimeters. But we also want it to be connected to the top and bottom, so we're going to set a coincident constraint on the top there, and then on the bottom. So now it's completely locked in place. I'm going to zoom out a bit so you can see everything there. Once this is done, we can finish our sketch and we can start extruding it. So we go for the extrude. And now we're going to have to really be careful what we are choosing, that we are choosing the correct rectangles and outlines while we're doing this. So if I focus on the knob that's going to protrude outside the wheel, if I click here, I have now marked just the rectangle that is outside the wheel. Because as you can see, now here you already see the problem. If I flip it to the top here, you see that the extrusion is curving away from the ring is curving away from my extrusion. So I need to also manage to mark the small thin rectangle that is on the inside there, the 0.55. And now we see that my extrusion is fused all the way over here. I haven't put the correct width yet, so it's way too big compared to what it's going to be, but it illustrates the point pretty clearly. Then I need to find the outlines down here. So first off, I'm going to choose the one that's hidden inside my disc, the thin rectangle that's in there. So I'm going to go over to the side here, and we can just barely... That one actually gets chosen all in one go, so that one looks good. And when I zoom in here, we can also see that we have the parts being fused together on the inside there. So now I managed to choose everything here. I've managed to choose too much, as you can see. I'm actually doing quite a lot more than I was supposed to do up here. So I need to hold down my control button and try to get the inner part of the wheel itself. Then I do everything there. Let's see. There, now I have only that one. It's a bit better. So right now, we managed to select the correct outlines on the sketch, but right now it's trying to extrude everything in one direction. And that's no good. We need to extrude it symmetrically in 2 directions. So we need to go over to the window here and choose the symmetric option. So we've gotten the symmetric one in. It's doing it in both directions from our sketch. But it's way too wide compared to what it's supposed to be. And it's supposed to be 12 millimeters instead of 19. So I go in here and I put it to 12. And then we get it perfectly here. So now we have fused materials all the way here, and we have fused materials all the way here. So we don't have any gaps between our curved surfaces and what we are extruding. So we'll click on OK. If I go up to the top view here, we can see that we've got one spoke in place. And now we're going to need to do a circular pattern. Just going to view it from the side here again. So then we go up to the pattern part up there and we choose the circular pattern. And what we're going to do for our feature, we're going to go over here and we're going to select extrusion 3, which is the spoke itself. And you can see it being marked here. And then we need to choose a rotational axis. And what we can do then is just to choose a cylindrical face, and it's going to select the center of that cylinder as our rotational axis. And the default one is 6 parts in our pattern, and that's exactly what we want. We want it to be 6 spokes on our wheel. So we'll click OK. So if we look at the drawing of the wheel, we can see that the knob on the outsides, they're supposed to be filleted all the way around. So that they're supposed to have an R6. And that's a bummer, since we've done a circular pattern now, then we're going to have to do fillets on all 6 of the knobs. If we had done the fillet before we did the circular pattern, then we could have just put it on before we did the circular pattern and it would be all okay. But there is a way we can fix that. We can go over to the browser tree here, and you see the red point there which says end of part. We can select that one and we can click on it and drag it up above circular pattern 1, and then you see the circular pattern disappeared. And what we can do now is that we can put in the fillet, we can drag the end of part back down, and that means that we will have extrusion 3 will have the fillet, and then we'll have the circular pattern. Because the circular pattern can only incorporate something that is above it in the browser tree. But then I have placed the fillet above the circular pattern, and that means that I can edit the circular pattern and include the fillet in it. So I'll show you while we do it here. So we'll do the fillet, 6 millimeters, and on the outside edges there, so that it becomes a nice round shape. Then I place that fillet. And if I now go back to the browser tree, and I drag and pull the end of part all the way down again, it has now placed the circular pattern back into my parts, but we can see that I have the fillet in place still on the original spoke. So one thing I can do now is to double click on the circular pattern, and I can mark the features one again, and I can also click on the fillet in the browser tree. And now you can see already in the preview it's put in the fillets on all of the knobs there. So when I click OK, we have it on everything. Whether or not this was quicker than actually just placing the fillet on all 6 knobs, that can be debated, of course. But in a situation where you had a much larger pattern, it would definitely be quicker. So it's nice to know that you have the possibility of moving this end of part up in order to place a feature in the middle of your tree there. Now there are 2 more things that we need to do to this wheel before it's done, and we have 5 minutes to do them, and I think that's going to be adequate. We're going to add fillets with a radius of 2 to almost all of the edges on it, because almost everything is to have a fillet with a radius of 2 on it. And then all the way to the end, we're going to create a hole through the middle with M14 threads. So we'll start off with the fillet. We'll change it from the previous 6 millimeters to 2 millimeters now. And we'll just start selecting our edges here. So all of the outer edges on the wheel, I didn't want to do that one. See? We do the wheel first. It might be wise to divide it into several fillets. So one fillet for the wheel, the outer ring itself, one for the spokes, and one for the central parts. I've gotten it all the way around on the wheel, on the outer ring. Now I'll do the same fillet on the center disc. And then I'll see if I can get the fillet going on the spokes. Can we get all of them in here? For some reason it doesn't want to do that one. Let's see. Don't get that one. Yeah. Because the weird part is it manages to do it on most of the spokes, but then I have 2 spokes where it doesn't want to do one of the edges. And this is something that you can stumble across in Inventor, and you will most likely never figure out why. At least in my experience. It's when you get something like this where just Inventor completely refuses to do what you want it to do, it's pretty difficult to figure out why it's doing exactly this, especially since it's working fine with a couple of the other spokes. So there is no real reason why it shouldn't work on all of the spokes. Yeah, so I don't quite know why I'm getting these error messages, but See if we can do a single fillet afterwards here. Nope. I'll do something different. So for some reason that worked. So I basically just used the same option as I did with applying the fillet on the outside here. So I went in, I moved the end of part past the circular pattern, and I placed the fillet on my spoke in the circular pattern instead, or on the original spoke, so that I could edit it into the circular pattern. And for some reason, Inventor accepted all of my fillets. So again, you will probably never figure out why it didn't accept them in the first place. So it's always a problem there. So just before we do a break, I'm going to place the center hole with threads on this one, because then we're done with this part. So I'm using the concentric reference because we're going to have it in the middle of the disc anyway. Select the top of the disc, or the bottom of the disc if you're looking at it from the other angle. Select the edge here so that you get the center point of the disc. And then we're going to have a threaded hole. So we need to click on this option over here so that we get the threads thread menu up here. We want isometric profile, and we're supposed to have M14, and on our shaft we have M14 with a 1.5 pitch, so we need to change the designation of this one. M14 and 1.5 pitch. We want the hole to go through the entire part, and we want full depth on our full depth on our threads here in the hole. So then we click on OK. What was the? You just choose M14 for it, then it's going to automatically set the correct diameter. then I'll just save the part, and we'll have a short break before we continue on with the last part of the lecture. Right, the last individual part that we're going to create in this practice task is the valve housing itself. So we're going to start a new standard millimeters IPT file. And just to make it clear before we start modeling on this one, this is a simplified version of a valve housing. If we were going to create an actual valve that was going to work, it would be way too complex for this course to do it, because you have some intricate channels going on the inside of the valve then. So we're just going to make a hole straight through the valve when we're creating this one. So this is not something that would work in real life. But still, it's a nice assembly training. So we're going to concentrate on the center part of the valve housing to begin with, because that's the part that we're going to assemble together with bolts and the parts that we've already created. So that if we can manage to get it completely done today, then we can actually just start the assembly next time with the valve housing half finished. That's a possibility to do that. So we'll start off with the valve and the flange that is supposed to be on the top of the valve housing. So we'll create a sketch. And since it's a flange, we're creating a circular disc. And it's supposed to be 125 millimeters in diameter. So we'll finish the sketch. We'll extrude it to a diameter, to a thickness of 17 millimeters. We'll create a new sketch, and notice that I've flipped my view a little bit, so I'm creating a new sketch underneath the disc I just created. And I'm going to make another circle. Let's see. This one is supposed to be 60 millimeters in diameter. So I finish the sketch. And I'm going to extrude it. And it's going to be 130 millimeters in length. So if I look at it from the top again, I've now got something like this. Then we're going to create another sketch, this time on the plane that's going along the ZY axis here, so that we are going to get the cut into our parts. So we'll start new 2D sketch. We'll move to the origin folder in our browser tree, open that one up, and we can see the YZ plane here. That's going to give us a cut through our parts. Once I've started the sketch, I click the F7 button on the keyboard so that I get a cut through my entire part. Then I'm going to use the project cut edges in order to get the yellow lines along all of the edges. Then I'm going to place a slot in here. So I'm going to use the rectangle option, open up the drop-down menu. I'm going to place a slot, and I'm going to use this one where I have the overall length of the slot and the width of it. So I'm going to connect it to the center part here, the center of the part. I'm going to pull it downwards here. And this one is going to be 70 millimeters. For some reason. Just start somewhere in here. We're going to set the distance afterwards with a dimension. Yes, in the middle. And make sure that it's vertical when you're putting it in. So it's going to be 70 millimeters in the vertical, and we're going to connect it to the yellow edge, which means that it's going to be 60. So it's 70 long, or 70 in height, and 60 wide. Then I'm going to set a dimension from the very top of the part and down to the center point of the slot. So the middle of the 3 points that we have there. And we're going to put that at 82 millimeters. You slot with the overall length. Yeah, because then you can set that the overall length of the slot is going to be 70 millimeters. If you use the 2 center points, you just have to set it as 10 millimeters for the length there. 82, I'll move this one so it's easier to read. 82, yeah. Just wait a moment. Yeah, it's just 180 because I didn't want to put it with an auto constraint. So I just had to write in 180. As soon as I approached 180 with my mouse pointer, it's jumped up to 60 degrees for some reason. So So it's just a glitch with Inventor there. It didn't want to auto-constrain it vertically for me. It just kept on jumping up to 60 degrees. So I had to manually set the degrees instead. Yeah. Yeah, the vertical constraint was just to make it on a line with the center point there. It was on a line, but I could still pull it away. Just between any one of these three lines and the center point up there. Okay, once we've gotten the slot into place, we'll do finish sketch. And then we're going to do an extrude. And we sort of have to try to find the outline that we have in here. So it's a bit difficult to find, but you'll see that it's slightly brighter when you mark it. So then you click on it. And once you've clicked on it, you select the symmetric extrude, so that it's going to extrude it in both directions. And it's going to be 200 minus 19 minus 19. We're supposed to have flanges on the sides here later on that are 19 millimeters thick. That's why I've removed those two with 19 there. So once that extrusion has been done, we click OK. And for now, we're just going to not care about the flanges on the sides, because we don't need those when we're doing the assembly. So we're pretty short on time now, so we're just going to do the stuff that we actually need for the assembly parts. And if you want to, next week when we're done with the assembly, you can fix your 3D model afterwards. So we're going to start a new sketch. We are now going to hollow out the vertical part of our valve housing. So we'll start a new sketch, and either on this plane that's going through it that way, or on that plane. It doesn't really matter which one you choose. Just use one of those. Again, we'll click on the F7 so that we cut through our entire part. And we're going to use project cut edges to get these yellow edges on it. Once this is done, we're going to revolve something after we've created the sketch. So now we have to remember to use the center line and not the construction line, as I did in the first one. So center line. And I'm going to place a new line up here. And it's going to go from the middle of the top to the middle of the bottom there. Once I've placed that center line, I can click on the center line function again so that it's no longer blue, so that I'll be placing regular lines instead. And then we'll start creating 1/2 of the outline of the part that's going to be hollowed out here. So start off with a line up top here. And I'm going to make a very small line to begin with, far out on the side here. And just make it not that many millimeters down. And it needs to be at a 90-degree angle to the line where it's starting from. Then I'm going to make another line going in towards the center. Need to go down a bit again. And then in towards the center again. I'm going to make a long line downwards here. Then I'm going to make an angle line I'm going to zoom in there so that we can see what's happening down here. An angle line first, then a vertical line afterwards. So the vertical line there, then another angled line. And then we're going straight into the center line that we have. So now I'm going to start putting in the dimensions for this. So I'll start off by putting in the diameter dimensions, just so that we get a feeling for the width of this one. So I'll start up top here. And here you can see when I have a center line instead of a construction line here, it automatically chooses a diameter. I don't have to right click and do linear diameter for it, which should have tipped me off in the first part we created. Diameter there is, and that first one is supposed to be 78. So 78 millimeters. And the second vertical line is supposed to be 62 millimeters in diameter. And then the long vertical line is supposed to have 47 in diameter. And then the small vertical line down at the bottom is supposed to have 47 minus 4 minus 4. So actually we could have done this a bit differently. We don't need to put a diameter there. We can do the dimension from this line to that line instead, with 4 millimeters. It's going to fit better in with the drawing that we're supplied with. And the same from this line and to the end point there. We are going to have 1.75 millimeters. So 4 millimeters from this one to there, and 1.75 from this one to the end point there. So then we'll go back to the top here and we'll start giving the lengths. Let's see. So the first one up here is supposed to be 2 millimeters. And then the second line is supposed to be 10 millimeters. If you need the dimensions, you have them in your compendium. So you don't need to see them on the screen. And from this line up here, and down to the start this line here, the top point there. We're supposed to have 110. So I'll zoom out a bit here so we can see the full length. The length from the 110 mark and down to the bottom is supposed to be 12. That's good stuff up. Let's see. We'll go back here. Let's see this one to that one. 10. Ah, that's what happened. Let's see. Oh, I need to remove that one. In order to avoid everything jumping around here, we'll set this dimension first. So from the point 110 point there and up to the top of the angle line, that's going to be 10 millimeters. So 10 millimeters up there. That's going to stop everything jumping around when we're putting the rest of the dimensions in here. Then from the same 110 point and all the way down to the bottom, we're going to have 12 millimeters. And then this last angle line is going to have a height of 10 millimeters. So we go from the bottom line and to the top of the angle line. And for some reason it's locked into place. Ah, it's locked in as parallel with mine here. So there. So Inventor had automatically constrained that line on mine to be parallel with that one, which meant that I couldn't change the height of it. So once I deleted that constraint, I am now able to put the height in as 10 millimeters there. Right, we'll just have to stop here. You have another lecture in 10 minutes, so we can't continue on. We'll do the revolution and then the holes in the flange first off next week, so that we can do the assembly. Oh yeah, I have to finish my sketch before I can save it.